Okay, let's not waste any time. We're live, are we? Yes. That was easy. Johnny, where have you been on the hangout yesterday? Hello, Johnny. Hey, Jordy. Hey, Tech. Test icicles. Hey, Christian. Oh, wait, I need to Twitch. Wait. Is Twitch running? Oh, yeah, Twitch is running. Nice. Okay. Oh, I didn't change the title. Did I change the title? No, I need to update the title on Twitch as well. Because it's a very complicated title. And nobody knows what this title means at all. Twitch. You know what? People seem to enjoy our Rickroll ASIC, it seems. It was the best video since a long time for the first 24 hours, but you never know what's happening after that. Oh, TTS, I didn't even start TTS. Oh, let me change that. Here we go. I didn't join TTS. Here we go. And okay. Bitluni join. And we are good. Have you been enjoying the good weather?
Bitluni TikTok version 4.2.0 starting da 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 da.
Oh, Korean name. I have no
Hi
clue how
all
to read this. Hello.
#Rand #not.
That was loud, lol.
Mod. Deshipu, hello. I thought about you today, Deshipu. I made kopitka today for for lunch. Hello, Asif. Hello, Rota. You were curious what we are what the title.
Your
title
TTS
means.
is streamed loony.
That's why my nose itched.
That's why my nose itched.
Work, that's just another 4-letter word.
Oh.
He wrote her in Dutch. Bitluni on stream today.
Okay. Sorry. Disabled Bitluni. It was still active from last time. Now Bitluni not on stream today. So today we had kopitka and I made cake, rhabarber cake. What's rhabarber? Rhabarber in English. Rhubarb. Yeah. Here you go. Rhubarb cake. We will have a piece later, I guess. Hey Z80, hello. Hey TMK. So any guesses what it means? Our title. Let me read the title. The title is really complicated today. DIY mini game CH32X035 light transmission and interpreter. Any guesses? Any guesses what's meant by that? Let me open KiCat. So you OnScripter. What is OnScripter? Maybe we have a solution already. maybe there is a solution out there already and we just need to activate it. It looks like this looks like warm white. Maybe I changed the color temperature of this light and that's why it looks a little bit off the temperature. No, it's 4K Kelvin. Strange. Yes. Yes, that's that, and we can flicker, basically flicker transfer. On script there's something to write. Visual novel? Oh, no. Hey, Sniff. Oh, wow, we have full house today. Nice. Alright, so let me open KiCad and let's talk about what we did last time. Maybe we can remember what happened last time. How do I hope I don't stream the wrong. Thanks, Asif. Yeah, I don't know. Probably. With Caravel with tiny tape out or with open lane and stuff like that. That's already possible. Especially using Caravel as a basis like RISC-V and then having just this whole real estate. But one chip is 10,000 euros. So if I don't want to share with other people, I need like 2 efabless. I need efabless to sponsor it somehow. Yes, light transmission, maybe IRDA like on some console. Yes, we can do that. I don't know if there is like a simple code to decode that. If we might want to synchronize. We need some synchronization code for that. But let me show first what we have here. That's that. Megaplex Light 35. That's our PCB. And you know, I completely forgot about this. Probably Rota. Hi, Rico. Rota probably remembers. We have the new chip here that we are using, the X35, and we had more pins. All the buttons are now on pins. We didn't read out the buttons yet, but we can do that. But there is something, we had like an extra spare pin. We thought, oh, maybe we read in the battery voltage or something. That, oh yeah, do you want to switch right now to KiCad 8? No. Okay, so we had a spare pin with analog capabilities. Is it analog? A9, here we go. And so I thought, oh, you know what? Let's put something like this here. And actually, I forgot about this. What is this? It's an LDR, it's light dependent resistor. And looking at this device, maybe, you know what? I can turn on the camera so we can look at it from close. I don't have a close. Oh wait, we can do this. I have an idea. This camera is the wrong way around. A cheapo light meter. No, we can use this to transmit data. Hello. joined. It's not updating here. Rico, hey. This is what? The HDMI cable. Oop. Let's see. Can we turn? Ah! Sorry. Fondue. Is this? Nope. Is this on? Where is G? Ah, yeah. Something like 30 maximum would be 20 bits per second. That's the maximum because we can only do. Let me put this down. Whoop. And hey, Chili Willy, 3D. I'm fine. How are you? Okay, so after the last stream last time, I looked at the PCB and noticed, is this a stray LED? I didn't even notice before. This is the LDR here. And there is the resistor, 5.1K. So we can just hey Ibrahim, yeah, you can help because I'm a lazy person and I need to like spit out the next video as fast as possible because I need money. I'm broke. And I mean, we have something already. This is the new version of the device. We need a new case because the other case that we printed was a little bit flawed, and we need a multi-part case that works better with the printing service. And yeah, reorder that. But printing a case is not the topic for the day. What I wanted to do is I wanted to put a simple code interpreter on here that can efabless. Yeah. We can do that. I wouldn't say no if efabless would sponsor me, but the pressure is high on me to, if it doesn't work at all, the final chip, and it will be wasted 10K. And we find out after half a year. That would be the worst. Okay, so imagine like a code interpreter that runs code. That's some bytecode, runs on this device, can access the sound like in some way, either frequency or PWM. You can set PWM or whatever, and yeah, you can set frequency. Let's say you can set up a frequency and then you can access each pixels of the screen, and then this bytecode needs to be like stored here. We either use the files, the mass storage that we implemented last time or the times before, or we use this light dependent resistor to read basically this flicker from the screen. Why from the screen? Either hey MC Thomas, welcome to the stream. Yeah, that was a good video, I would say. I struggled a little bit with the B-rolls and the footage and everything, terrible editing for days, but I finally got this out of my system, and now we do that, and then we do the persistence of vision project on the ASIC, which is really cool. Your own audio video format? What? No, what? No, not all, no. It will be just, you will be able to write code to run on this device, and you can either transmit using a copy from one device to another with flickering the screen and using on the receiving side the light dependent resistor, or you can hold it to the screen of the computer and upload your code like that. Hey, Paulus. Yeah, so why from the computer? Because we can do a browser IDE with emulator for this device. Light of the screen. If you use the browser, this screen is way faster. We can flicker, what was the frame rate? 32,000 frames per second divided by 3, because you need always 3 bits for reinventing the wheel. Yes, you need always like 3 consecutive states. Either you have a long phase or a short phase for 0 or 1, and this is how you would, if that works even with that, but the analog read should be fast enough, I guess. So transmitting from this device to another device will be way faster than transmitting from the computer screen, because the computer screen can do maximum 60 frames per second typically. Probably you can do more with like, I don't know, tablet or whatever, or with if you have a better screen, but usually I would aim for 60 FPS, and you can control that because there is in the browser, you can do like animation callback, and it will basically do like the full refresh. I don't know if it's hard-coded to 60 on the browser or uses the native frame rate. Hey, Sniff, what? 10 pound? What? Thank you very much. That's a lot money. What? You want fondue? Oh, my room is stinking so much because this room is way smaller than my old lab. Every time I use fondue, I suffer like 2 days after that because the whole room stinks like fondue cheese. But thank you very much. I will check out if I can get fondue, because here you can't get easily. Either I order it or yeah. But thank you very much for the super chat. All right. So why not create a programmer for that board? Because you don't have the programmer. I can do like a file download and drop the file on here. That's another option. So if I have like an IDE in the browser and then I click download, it creates a binary file that I can just shift on that, and then on the receiving side I can just read it in and interpret that. Or I have something that's really like super easy. If this is like a key fob and I go somewhere to another place, someone else has this, we can just transfer without an extra tool, which is really cool. Yes, okay, the Shipu, let's do that. So, let's do Lua. I can do Lua with you if you help me with that, because This is very hardware dependent. Everything is really hardware dependent, and I'm reinventing the wheel over and over again with each platform. Having correction today? Cassette loading routine? Oh, okay. Yeah, we have to check that out. And then increase the... It's easy. Okay, let's find out how to do that. Let me, yeah, we need, I show you paint. Let me paint. I know Lua only from DaVinci Resolve because that uses Lua as well. So, why is this? Here we go. So this could be a monster stream today because I want really to make progress. Where's my draw thingy? Okay, so this is how it works. We have a computer, beep, 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 here. With 2 disk drives, one with the operating system and one with the exchangeable disk. And then you have this mini device here with the buttons, boop, 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 boop. And basically the screen transmits to that. So you transmit the bits here. 1 0 1 1 0 0 1, like that. And what we receive here is a stream of flashes, and you can say this is a 0, this is a 1, this is a 0. Oh wait, yeah, whatever. It's not the same stream, but we will just decode it again. 0 0 1 1. Here we go. So how is that decoded? You sync up with the rising edge, and that's basically always, oh, sorry, shit. Sync up with rising edge. It's always the same time. So this is basically DT. It's always the same. But this phase here, if it's short, that's a 0. If it's long, it's 1. But you need this downwards edge here. So the shortest let's say resolution, or the smallest resolution that you can do, is basically 3 bits to encode 1 bit in this transmission method. Hey Manuel. So this will be 0 and then 0 1 1, okay? And so imagine this is basically then, let's say, white. This is black, black. So we need 3 frames. We need 3 frames. White, white, black, white, black, black. These are basically the flashes of the screen. So if we have 60 FPS, we can reach 60 FPS. I don't do error correction here. Let's forget about that. Let's not do signal. Oh, Manchester encoding. but it might have. Yeah, I don't know. We can do smaller packets and then basically do some parity bits or whatever and check, ignore, repeat the whole smaller package. Yeah. Or we use packets of like 32. Let's say our whole code is 256. 256 bytes is the maximum code that you want to transfer. And then you have basically, you repeat it. And then you have like 16-bit chunks or whatever. 16-bit chunks that you read. And then you have like extra parity, whatever, 2 bits. And if the parity doesn't matches, you ignore the chunk and wait for the next iteration. And if you have like matching parity, you accept the chunk. So, and this is, you don't accept the chunk and something like that. That could be a transmission protocol. But what we can do right now is, so this is the goal. But we are not done yet. This is just a communication protocol that we can refine, reinventing the wheel, trying some typical. Let me make this bigger. I can't make it bigger here. Whoop, whoop, whoop. Here we go. So what we can do now is forward error. Oh wow. Yeah, you give me the code then, Rota. I can't remember the stuff. Manchester encoding is one thing that is more error proof. But basically, this is what NeoPixels do. NeoPixels use the same protocol here. And that's it. They don't have no error correction whatsoever. It just works. If it works, it works. If it doesn't, it doesn't. Bitluni encoding. Yeah. Yeah, that's the theme here. 20-80. 20% effort, 80% of the way to go. Or the well, this is the one thing. Now imagine you have a browser IDE with some code. This is code. So code. Yeah. Okay, so code, and you have basically this mini screen, which is like 16, in this case 16, we can do it generic. So if we have a new console, we can improve that, and we can do Lua or whatever runs in the browser, or we do like a super simple assembler. I would start with the super simple assembler, and then you can share your code. Share. Yeah, you can't read that. You can share your code, your game, and I can basically upload it. I can paste it here, whatever. We can do like some base 64 encoding and just drop it in the chat, your code, and I can paste it and then upload. Upload it here. And it will flicker it on the device, and we can play the game that you implemented. But please don't send dick pics. But are browsers that precise of, yeah, they are. Request animation frame is the keyword here. So you can do exact 60 FPS if there is like one dropped FPS or whatever. Just repeat the packet. I show you request animation frame. Yeah, this is basically what you will use. Where is my here? Request animation frame, 60 Hertz. Most common, but it supports. Oh, it's interesting. So what? It doesn't really matter. You can make it. Like the receiving side, you can make it synchronize itself. Self-synchronization, super easy, because you will just measure, like calculate the median or whatever, or adjust. You just need like the rising edge. Detect that, and you have the next rising edge, and then you can basically. And let me show that. Okay, request animation frame. You have refresh rate 60 cycles. If you have a faster screen, even more. Yes. But I just want to use this light thingy that we just put there out of curiosity what we can do with that. This is PinkLink, basically PinkLink 2.0 with an actual LDR, no LR light dependent LDR, yeah, LDR on there. So let's just use it, and we can transmit even without USB cable between the devices themselves, and they can use a way faster rate. So yeah, you can basically, you can, if we produce that, if we can manufacture it, we can basically, you go in a convention and just share your mini games. Oh yeah, something like that. That basically like remote controls. Remote controls use something like you have. Where's my drawing cursor? So start frame is basically like they use 32 or something. 32 continuous like high or something, and then low. And then you can detect, okay, that's the start. So this is like unusual that you have a span of that. Yeah, LED can be read. Fire or even LED. That's what I put on my on this thing here. So this is PinkLink. Let's show that. You might not have. I don't know if you know this project, but basically, oh, what shutter speed is this here? Oh, shutter speed of 400. Okay. Here we go. Yeah. Yeah, we don't need to do that. We don't need a snake, and we have something pink. Yeah. This is just a clear pink LED, and we have it connected to an analog pin, so this could be used to transmit. This is the El Cheapo. It's a $1 bomb cost device, and yeah, it has only 6x6 display. And I implement we implemented on stream every app here and now we have to reinvent the wheel with the new device here. I'm sick of that. Let's do like let's do a Lua interpreter or whatever. We might have enough speed, but what I'm worried about, I would use JavaScript because I love JavaScript, and probably we can do like an interpreter, but then you have to implement also a garbage collector and so on, and we don't have a lot of memory there. So I don't know, but I would, if Mr. Durapielski can find a simple open source Lua interpreter, we can do that. Nokia phones use transmission to transmit data. Yeah. Yes, you could. With the Nokia, you had infrared, like the 62. I had one of those. They had an IR thingy. Also the Palms had IR, I think. Yeah, back in the time. Yeah, so self-synchronization, really simple. You can see you sync up. It doesn't matter what the frequency. Why is it? Yeah, hertz. Yeah, hertz doesn't matter. You just sync up, measure the time between the rising edges, and that's it. You can do 10 kilohertz. You can do 20 hertz. All right, so we cleared that. This is like one goal, but I would start with a basic interpreter and design. So how do let's expand this. Whoop, paint. Here we go. Let's expand even more. Let me shift that to my 4K screen so I have more room to expand this file. So how do we design our if we can do Lua in some later point or a C, I can do even like an intermediate step. If we have like an assembler, what do we need? We need something like, do we use registers? Or do we use just variables? We need something like add. Do we need subtract? We need neg. That's like 2's complement. Two's complement. Then we have and or mul. Let's do that. Diff. Let's do even that. Oh yeah. Wasm. Oops. That's in the browser, wasn't it? Can you do you have possibilities to you can Manuel, I give you, if you want to drop links, I can give you moderator. And you can drop a link to some information how to like information about WASM. Okay, what do we need? We have not is missing. Not. Should we do sub? Yeah, let's do sub. Mov. Ah, XOR. Oh yeah, you're right. XOR. Then we need jump. Jump. Then we need something like compare. That checks for flags, and then we have jump 0, jump greater, and jump. No, we don't need jump 0, jump greater, jump equal. Since we probably won't use registers, we can reverse the parameters for the compare to have the smaller. Negative, jump negative, do we need that? No, we can basically compare to 0. Stack based. Yeah, but like the FPU, jump 0, we can ignore jump 0 and basically make stack based. Python VM. A stack based. I have no clue. I don't want to make it complicated. I would just make a memory and do it like that. First byte is yeah, that's like FPU on the x86. Oh, that's a good one. We can do that. That's the Polish reverse Polish notation. Every operand knows the. Okay, yeah, let's do that. Nope. Nope is basically CMP. Oh wait, no. You can do and to like and 0 0. Whatever. A custom board, yes. Tyler. This is what we are developing for quite some time already. It was a joke. No, for timing, it's not a joke. If you need like precise timing or something, you need like operations that do nothing. Okay, do we like push and pop? Stack based might be it. A 5 by 5, that's really tiny. Okay, but we need some sort of encoding. So yeah, mol and diff is very important because we want like floating point bimanual. Where's this coming from? I can see text in my emoticon triste. Okay, let's open this. By the way, here, this is still my folder with the tiny tape out stuff. Did you see that? Oh wait, no, this is way too where's the highest resolution? This is not the highest resolution. Huh? It doesn't show the highest resolution, but the Caravelle, we have like a really big file. Look at this. Yeah. I show you the cover from the video. I have all versions of the cover here. I have best chip, worst chip, even bigger hand, but this looks really strange already. So even bigger hand, and these are the faces that I made for that, and that one made it. Worst chip in the world. Yeah. Yeah, we can switch it and see how it behaves. Yeah, the faces always work, huh? That's what the clicks where the clicks are coming from. Okay, now let me create a file and we will start just coding. Yeah! And then everything will form from that. Megaplex. Here we go. Megaplex code, and then we have IDE, and this is where we create an HTML IDE. Yeah, everything is docs. HTML, and then yes, and then we do like an interpreter file. JS interpreter, and then do we want to split it? I don't know if I want to even split it. Let's do visual code, new instance. No, we will do in code. Here we go. This is the new code. But I could if I here we go. So body head HTML head body, and then we have document doc type. Here we go, HTML. Body, mind, soul. Yeah, doc type. We have script source, and then we have interpreter. What was that? Exclamation mark. No, how is it script? Is this how you include the script? I forgot, dudes. I forgot completely how to. Body. Let's do script. Script. Ah. Shit. What? What? I forgot how to function. Why is this? No. Script, source script. Yeah, we can do that. You missed it. Body onload. Onload init. Init. You know what? Let's do. What are you doing? Okay. HTML. Do I? Okay. That's HTMLS. No, XML. Something like that. Okay, here we go. Yeah, XHTML, but then we have like to just do XHTML, and then here we go. We can do the thing. All right, in it, then we need, what do we need? We need a canvas here. Canvas. Yeah. Are you enjoying it? 515. Canvas, and we need style. Should we style it here? Style. Canvas. What's yeah, empty rule sets, I know. Okay, then we have what is the pixelated pixel? But that's all right. I don't need to know everything. Image rendering pixelated here. Do you know that one? No, you don't. So zoom 16. Let's do big pixels. Here we go. And then in it, let's do canvas let CTX be 0, then document query select canvas get context. I don't forget anything here. So here we go, context. No, we should do canvas. Canvas equals and then canvas get context, okay? Yeah. And then we lat, yes, latitude. And then we just write a pixel. So CTX get, no, what is it? How do I get the pixels? Ah, come on. Image get image data. And then we will do image data equals blah, and then function loop. Hoppala. Get image data. Outsourcing the image. What? Get image data. Yeah. Oh, we should do. Const xres 16 const yres, and we can do basically canvas with, just to be sure, if we change it at some point, that we just need to set it there, canvas. A fly? Oh no, it's terrible. Ah, fuck. Escaped. Is it so warm already? Hate it. Obnoxious things. Okay, then image data. And we should, yeah, no, image data, I think was data, and then we have function pics, RGBA. Oh fuck. Ah, got it? I don't know. I flicked it. I think I got it. I don't know where it flew, but I hope it doesn't recover. Pics, or do we do dot. That's a pix. It's square, so. And then we do basically image data. Const p is basically x plus y times x res times 4. That's that. And then we have p equals RGB. Foo. Yeah, let's do RGB. And we do it always opaque because this will be simplified. So let's try 1 pixel here, get image data, and then we just do pix, and then 0, 0, and then x 0, 0, 0, 0, ff. That should be just red. It's not the bitluni red. The bitluni red is this one here. Should we run it? Oh wait, we can go live with that one. Where is it? This is it. Something's broken. I don't see a canvas. Yeah, pix. Assignment to a constant value. What? Oh yeah, that's. We are incrementing it. Okay. Now it's. Where's? What? Oh yeah, we don't put it back. Yeah, so we need here request animation frame. That's window request animation frame, and then we do just loop. Here we go. And then loop. Request animation. We can do it like that. We can run it in a different request animation frame. I think it's a window. Is it window? Yeah. So by default it should be that, and then we just do canvas and do basically not canvas, CTX, put image data, and then 0, 0, and then image data. I think it was that. I'm not sure. Let's see. Put image data, arguments. No, what was? Huh? Hey, Aaron! Welcome to the stream. You missed the introduction of very important stuff. We have, we will do for this device a wireless light transmission protocol, and then we will write an interpreter to and an IDE. Where is this cursor? I can see it. Here we go. So transmission over light from the screen, and there will be this IDE that you can write games for with, and an interpreter for this that emulates this device, and you can write on your PC code, and we will just upload it to this device and run it here. This is the plan. This is the plan, but we see nothing like basic state of common state of common state of coding, graphics coding. Put image data. Does it stop here even? Yeah, F8. What was there? How does put image data? Ah, image data is first. Okay. Yeah. That's it. Draw frame. I like graphics coding. Yeah. Here we go. That's bitluni red. That's bitluni red for you. Code is done. You're proficient with flex boxes. What's the new style of coding? Not tables, it's flex boxes. So I don't want like the table, I want like a flex box, or what do I want? Teach me. TR, TD, grid, Rota. Okay, let's CSS grid. Is this like also resizable or? Okay, let's take a look. Let's educate us. Okay, tables it is. Way too fancy. Let's keep it to what we know. TR. Oh wait, TR and that's row. TD, TR. Phrase it. And then we have here what's text area. Text area. What? What is that? Is this a template? A name? I don't need a name for the text area. Code. Calls. That's interesting. Columns and rows. Let's see what it did. That's text area. Wait. Huh? Oh. Sorry. TD and TD. Here we go. We can do new line. Whoops. Yeah, I was in the wrong. Here we go. It can also have TH for a header. Yeah, that's the screen and that's the coding area. And this is centered? Yeah, I think the canvas is big like that. Okay, so let's do canvas. Let's give the canvas a border. Border style solid. Yeah, that's all right. Solid. Do you want like a dark style? Dark style. So body, whoops, body, and then background color will be black. Or do we like dark? That's not asphalt. No. Shit. Okay. Let's do. Still a little bit too dark, maybe. Some stuff here. Okay. What do we have? Like borders are quite border color color is basically 444. Thickness maybe 555. Pink. Yeah, you need to give me the pink color. Paste it. You will get it. Border thickness. Border width, it is 1px. Oh. The whole thing is scaled. Okay, let's do that. Pink border for you. Oop. What's going on? Huh? Huh? What? What? What's going on here? Huh? Here we go. Oh no, Christian, this is the worst. True hole, removing true hole again is so terrible. Just throw it away. Okay, now we need to text area. Text area. Client. No. Background color. Ah, my arm is itching. I think I have a dry skin here. Background color is our, what was it? 222. Here we go. Or do we? Yeah, that's good. I take that. That's our code. We can resize it. Oh, that's terrible. Terrible, and I like it. No. Align. Wait. Style. Align vertical. Vertical align top. Oh wait, that's the second one. I should do it on both. Yeah. Okay, and then how many lines do we want? Code rows 64. Oh, that's no good. And columns is 80 columns. Whoops. 8. Hey, come on. What is this? Like a real IDE. Here we go. Can we do some like, how do we make it flexible so it only fits that and good is? Yeah, let's not overcomplicate it. TD, and then we have span. How is this? Vertical span. Oh, come on. Span TD. Call span it is. So call span to. Oh wait, you need controllers here. We need some. Oh, we can just put it here. Call span. That's. Oh wait, row span. We need row span. Row span here. That's what I want. Okay, so we can put buttons here, upload buttons. We also need this is our, yeah, let's do BR, then button, left. Left. No, let's do R, L, R. Up, down, button left, A, B. What's the, no, B, A. We have this order. Boop, 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 boop. Isn't it cool? Yeah, we can do that. But the button background is, yeah, whatever. And we just need some interface. It doesn't need to be perfect. This will be an open source, so everyone can contribute. How do I make it open source? Let's create a JIT, initialize repository. Nice. Do we need like readme MD? Yes, something like that. What is this? No, why? What? What did I do? Stage changes. Commit. No, we need more files here. Readme MD. Exclamation mark. No. How do I do it? Open source interpreter for tiny game consoles, game hashtag, and this is, how do we, can we preview it somehow? Is there a preview? What open source license, take it and run 1.0. Why? Because we can. What? Why? Okay, yeah, that's good enough. All right. Add this and then commit and then publish it. No, publish branch. No, how do I publish? I put it on GitHub. Private public repository. Here we go. Using that feature for the first time. Now, how is it called even? I have no clue what's the name of this repo. What did it do? What did I do? This, I have no clue. I don't see, where's my repositories? Wait. IDE. Yes! It's just IDE. Here we go. Look at that. Nice. It's working. It's working. Yeah, you can participate. Huh? Yeah. It's working. I just show. Okay, yeah, cool name, huh? Very unique. What we need is now the second row with TR with the upload buttons. TR or run, upload, whatever. So more buttons here. So run, downloads, or save, upload. Load, but that will we don't need that. We don't need that. We only need run. What? No. Please. You know there is no support. Ah, here we go. Nice, there's no TD. So the first one has call span too, so it should appear here. No, it doesn't. It appears here. Oh, okay, yeah. Because we don't have TD, and then do basically vertical align top, and this is it. I don't want to overcomplicate things here. Let's remove the style. Here we go. And then the other one will be top heavy as well. Why is this so tiny? What did sniff do? Sniff. And there is a branch. Yeah, Casper, you missed everything. Oh, you have to scroll back to the explanation. Okay. Short recap. We want to use the screen or LEDs to transmit over with the LDR. You watch stream, okay. Ugh! I flicked the fly again. I don't know where it went. Flicking it is most effective because then it's stunned and you can, like in D&D, if get stunned you can add free attack, like with advantage. I don't know why this is. Okay, that's good. You doubt that? You doubt that? Look at issues. Oh yeah. Where are the issues? Issues doesn't work. Louis, your avatar is a little bit dated. Let's see. No, forever young, Louis, bitluni media. It's the ultimate. Oh, GIFs. Fondue. It's fondue stir. This is like bitluni media. Audio. Okay. No, let's not play it. No, view raw. Okay, that doesn't play back. Nice. I will watch. I will look at the things later. Why is this not? You know what? F this. I will just put it in the same row with BR. 2 BRs, like to make it more stand out. Yeah, here we go. So, what do we want? What? Not to be? Okay. What is a border color? This border is terrible. Okay, border text area, border color and border width and border style solid. Oh, wait. This is 1px because it's no style. What is border style? Solid. Because that's like some stupid... Yeah, okay, cool. Let's do 2px. Yeah, looks good, our IDE. How does this IDE look like? Is this like more grayish here, that area, or is it more darkish? We should do like a different type of gray. Let's do 444 and then... Ooh! Sorry. And let's do 111. Okay, that's code. That's code. Yeah, we can see the text color. What's the color? Pink. Pink again. Everything is pink. We could just... Okay, yeah, that's good. Is this like a courier or what is this? What's the I? Yeah, it's actually code. Nice. Okay. Here we go. If anyone has a nicer font, we can use that. So, we want a stack. Okay, let's do aria controls accessibility nightmare. It works. If it works, it works. Yeah, that's it. Canvas background column. Background color is black. If it's black, it's black. Here we go. 1 pixel. Okay, so we want some default text. Default text area. Let's do some push 16. Push 16. No, push 15. Push 15. Push 6. No, then we need a label here. No, code number, line number. Do we number our lines? Can we do text area with line numbering? That will be way easier. Oh no, we need labels. We need labels because you can't insert text if you are. Or we do it this assembler as an intermediate step and then do some C compiler to or JavaScript compiler that generates this code. Oh, look at that. Look at that. You just type, let me show that, numbered. Huh? Yeah, no good. But I don't see numbered. What? Numbered. Oh wait, that's a class. Huh? Yikes! No. No, 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 no. We don't do numbers here. Syntax highlighting. Yeah. Code Mirror. There's a plugin. Code Mirror. Oh, wow. Code Mirror is a nice thing. Okay, this plugin. Let's do push 16 and then let's code. Let's code and see what's happening. You can implement Monaco editor. What is a Monaco? Hey, OMG. What's a Monaco editor? Yeah, that's what I want. That's what I want. Plugins. Open source. We should just take that. Can we run it? Okay, let's keep that open. I just want a start. Okay, let's do labels. So let's do. Oh, come on. No, it will do. Okay, let's do Y X. That's the labels. And then we need Monaco is what VS Code is based on. Yeah, I'll rewrite just a VS Code plugin to emulate the mini device. that I take that. You can run from GitHub. You can run basically VS Code. Okay, so now we want push who knows what's happening here? Yeah. Why making web editor complicated? But I don't know how to do that. I know how to make a web editor and all the complicated things. I'm already at developing the codes. It's also JS. Yeah, that's cool. How does that work? How does it work? VS Code plugins. Do you have a nice tutorial somewhere? Or should we ask ChatGPT to write a plugin? But it's faster? Yeah, you're right. I don't know. If I struggle with the plugin, then so what's the things that you have to do around it? Maybe I should prepare it, and we will do another session tomorrow with trying with that, because now we are already done. The only thing that we need is the interpreter right now. Okay, we want to move. We want to push. Wait, no, that's not correct. Push 16. Push that. How do I pop on? We need registers if we do a stack-based interpreter. You don't have time for streams tomorrow. Oh no. Yeah, that's why we do everything we can now. Push, push. Push. Then we do push. Or how do we copy the stack contents? We can just put something from the stack, like sp stack minus everything is. Do we? Yeah, we ignore it. Stack pointer is 1, 2. Zero is a free space. That's -1, -2, -3. So we copy that. Then we push basically a color. We can push a color which will be 000080. That's RGB. We don't care, everything is integer in that, like 32 bits. SP, and then we do move. No. Load, store. Store. Yeah, that's right. You're right. What? Oh, yeah, you're right. Tab. You're right, you're right, you're right. Let's put some order. How do we want to move? Okay, so what I want to make a drawing method that goes through all the pixels, through all the lines, and I don't know, store. We can also do some kind of counter, whatever. But this is like, I mean, this already is way too complex. Having registers would be way easier. How many registers do we want? Nah. Let's see what happens. Let's see what happens. Okay. Let's assume we write a pixel here. Infinite registers, like a Turing complete. A Turing complete thingy. Okay, now we basically decrement jump node 0x. Oh, the stack is so... the stack thingy is really complicated if you want like to basically, I mean, what do we do now is we pop then we deck jump node 0 y. Technically, 0 page is for it, but STA LDA works on every memory byte. Okay, so this is a loop. That should also pop to clean the stack. Pop to clean the stack and pop to clean the stack. But now we have the problem that we don't have a variable to... Where do we store our stuff? It's basically, you know what? We do it like that. We have memory space. Let's say our memory space is I don't know how the space memory space looks like. Push and db0. Oh, you want to references to variables. I would really like to keep it as simple as possible with the stuff. I don't think we will do assembly here. And we won't do db0. We can do... Now I rather take something like move or store. I don't know. They use something like without E for maximum, huh? Store, and then we do basically, this is the address, and the address will be x1. Yeah, that's what we do. So we push that on stack, then we store it in memory. This is our memory space. This is our screen space. and then we push. We can, what is this? Oh yeah, we can do push that. Is there a new phone? Pixel 8. Push and then push that and then store. No, wait. We have, oh shit. The problem is, how do we store? Wait. No. We need to store this. That's the thing. We need to push. There is no address. That's just fixed numbers. Okay, we store the address first and then we do the store. Okay, it crystallizes itself. Push store. push store. Then we have load. We need like a load that will be basically push that, and then we need load. No, load was basically a push. Push store. How do we explain that this is also a push? Okay, I will explain. Push, and then we need, wait, push that load. Oh yeah, the Shipu, you're right. So you mean like also the flags? No, oh shit, this is so complicated. This is really complicated. Okay. We do this again. We load it. Yeah, I started with basic and then went straight to 886. And then Pascal and C++. Load. Wait, we load it again. Then we decrement it. No, increment it. And then, oh shit, no. We need to push. Does the load? No. We just take one. Okay, so let's do. But it's a cool language. Okay, so we push, load, increment, store. Then we do dec. But this jump not 0 does nothing. jump node 0 does nothing, then we have a pop. That should be it. Put in for a couple of knobs and okay. I will explain. So, yeah. Puts X on stack. Then we have, or pushes. We will just extend it even more. Oh wait, sorry, there is something missing here. A on stack, then pops 10 as address and pops XA as data and stores. Okay, that's that. So stack is clean. Then pushes 15 on stack. Pushes 16 on stack. Pushes on stack. And then loads pops x1 pops as address loads from address and pushes on stack. Okay, that's the description of that. And then we have pushes red, RGB red on stack. Let's do more comments here. That's the, you know what, we can start the memory address here. That's basically user memory. Then we have frame buffer. Then we have, that's all good. Let's start it with 0. More knobs. It's more like Java VM opcodes. I would totally use Java or anything that has good bytecodes, like the simplest bytecodes, and I will implement the bytecodes and let everything else do the compilers and so on. We can do that. I have something that works in the browser would be the best. Pushes address tools for store back later. pushes address to for load loads value pushes loads value and pushes. Oh wait, pops address. No wait. Oh shit. Yeah, pops address loads value and pushes on stack. Pops value increments pushes value pops address from before no wait store wait we need like pops value we need to do the right order, like reverse order here. Okay, pops 0 address and wait, value and here is this is wrong. Stores value to address. Okay, this is basically the same except here pops value pops address from before and stores value to address from before. Yeah, that's pops value .16 pops value decrements and pushes. Then pops value compares pushes back and jumps if not 0. Okay, and that's basically the same. Jumps to X, jumps to Y if not 0, and then we have pop that already looks like it could work, and then this A address is an homage to VGA modes. Whoops. Okay. Let's tokenize it, interpret and run it. That's our code. That's a code filling the complete screen with red. Isn't that cool? Oh shit. Then can we let it overflow? It shouldn't new line here. Why do we have an extra? Huh? Why is here? Okay. Huh? Scroll? Why? Oh yeah, wait. Is this because we made it columns here? Will it be now like stupidly? No. Yikes. How do I make it? Huh? So overflow X? Wait, that's text area. Text area. Overflow scroll. Overflow clip. Overflow auto. No, it's not wrap. Text wrap. No wrap. Here we go. Cool, that works. Okay, now let's identify. Let's check what the problem is. Store, there is a bug. Store. This is probably because the tab width. If it's in the beginning, it doesn't matter. But in that case, yeah. What do we have here? 4. All right. Text area tab size 4. Here we go. Fixed. I want to make this stick to the right size. Okay. Store, whatever. Who it works. It's not bright enough. The text should be maybe brighter. Yeah, whatever. But it's hardly hard to read. Can we run it? Okay. 2 hours and we have already developed a programming language, made IDE, even without using ChatGPT, and developed basically the whole system that we want to use to like distribute everything. I invented an app. CSS whitespace pre? What is CSS whitespace pre? What is that? What? Kinda impressed. Yeah. Yeah, we are good. We are good. I would say totally was a productive. No, it's not end. We just starting. This will be I hope you don't. Why do we have two B buttons? This is a complete failure, okay? A complete failure. Copy paste. Here we go. A. I would say this is something to add all. Where is it? Where is it? Open in editor. IDE here. Yeah, here we go. Add example code. Here we go. Sync changes. Yes, do it. Now we will do run the interpreter, which is basically class. That's not JS, that's already ECMAScript. So we need to change the file to interpreter, and then we have, what comments do we have? Let's just clone the code. So we have push, we have store, push will be V, store, then labels will be basically we don't know yet. We don't know yet. Label will be, we need the converter, like each line code, like a RISC, in the RISC architecture, each opcode has the same size. Whatever, labels will be done later. I don't care. Push, we have push, load. Load is loads something. Push, load, increment. We have an increment. We have, this will be instruction pointer. No, what is this? Let IP be 0. Oh, do we use like a instruction and variables? Let stack pointer be stack code. No, let's do stack pointer will be this, code will be this. This is all we have. This is all we have. Function. Yeah, Inception. Store load function. We could also do, nah. I don't know. We might want, nah, let's keep it like that. function, let's do let stack be so stack pointer isn't needed at all. Hey Max. Store we don't have a decrement yet. So let's do decrement function decrement jump not equal, and then we will have a label function label to address. We don't know. Instruction pointer doesn't really. We can keep it 0. Stack pointer is needed because we have an implementation of the stack like this. Even though it will be harder for us to. We have to rewrite this in C++ as well, which will be funny. And we have a pop function. Yes, we're writing. We just developed a new assembler. Label to address, and then we have label. Wait, label to address we have already. Uh-oh. I see an issue. We could do if the jump could be oh shit. We might want to do something like that, like add. Oof. No, I have an error here. This is, we need to do something like that. Push X. Pops address. Pops label. Pops value compares pushes back value and jumps to label. Okay, so we have just address of label. Yeah, in this case we can also use variables at this point because we see you later. Push Y, and then we do the same here. Huh? Wait, no. Huh? What? Why is this here? You could do labels. who suggested it? Kasper, was it you or Rota with DB, like byte or whatever? Because now we have to implement labels anyways as addresses. We could basically make the data segment implement just like labels here. And then initialize them with data. So yeah, that's actually it's more opcodes now, but the only opcode that uses data at all is push. Everything VM stack. You made VM stack machine? Oh no. Reinventing the wheel. Okay, jump, not 0. Now we have everything is except for function pop. Sweet. Return and then stack. Hey, making devices. We are implementing an assembler for an interpreter that will run in the browser, so you can write your own games that will be uploaded over light flickering to the game device and play there as well. No branch? Yeah, not yet. That will happen later. Stack pop. Stack pop, and then we will do sweet. Okay, so now is we don't need that. That will be the converter will do that. So let's keep it away. So now we need to implement what we did here. We have stack push v. That's it. Then store. That will be basically stack pop. What's the first? Store is pop's value. We have address and value. So stack we have address, value. Okay, so address stack, then we have memory, our heap be new int 32 array, and then we do, what is it, x, here we go, that's the size of our array. What is this, quick fixes? Yeah, let's do constructor. No, what is this function constructor? No, how does that work with the classes in JS? I forgot really. Or ECMAScript. Check that. Yikes! Okay, it's just constructor, okay? Here we go. Oh wow, there is no function here. No, oh shit. Okay, let's do this. This IP. This. Let's do all that, and then we need to. We need to diss everything. Go away here. Phew. Yeah, that's how you work with classes, huh? But we can run multiple VMs at the same time at the end. So push, store, loads. This. This stack pop. This heap. Value we need to VB this equals V. That's our store. This stack push. So that stores. Then we have load, which is basically push. This push, nice. Okay. This heap, this stack pop. This is correct. Load, pops address, loads from address and pushes. Yeah. So simple. We have increment, which is basically... let's do that. V, and then with this push V plus 1. Easy. Decrement is same. Same. Jump not 0 is basically modifying the stack pointer, which is stack pop address. No. Let address be... No. Address is beforehand. No. What is first? No, label is X. Okay, so we have address later. This is value. No, this is address, value. This is address value. Does it leave the value? Yes, that doesn't. Pushes back a value. I don't know if it should push the... Let's not push it here. Should we decrement it it feels a little bit inconsistent that jump doesn't, that jumps only pops one. But oh well. Oh wait, we can just pop here. We just, yes, as always. Pop, pop, pop. We can do everything pop, pop, pop. Pop this push. Value. If value not 0, then we go IP. This P equals A. And that's it. That can already yes, easy. Look at that. That's so cool. This pop 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 stack pop 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 pop. So easy. This is probably Turing complete already. Maybe, I don't know. I'm a little bit hungry, but I made a rabarbar cake. I will get some cake. Yeah, I made rabarbar. Here is food can. It's the time of the year. No. Rhubarb, yes. So that's yeast dough, and this is I don't know this. I think this is typical in Poland. Yum yum yum. Crumbs. It is delicious. A little bit sour, but I like it sour. Smacznego. Dziękuję. Kasper. And before that I had for lunch I had kopytka today. Kluski serowe. Hey Dave. Yes, you can. I think you need like color. I might work, I don't know. Dave. Worked, yes. Yeah, we implemented it. JS, no, CSS. You can basically inject CSS. Some people have even like rainbow background, just injecting some more CSS there. We have the senpai, yeah. we need a constructor which is basically code we have no initialized data. What if we make it even more obnoxious? No, we don't do this. Here we going, what if? I have a slight issue now. What is happening there? Ah! Dogs. Why is this so big? Oh yeah, I made... No. So how do we store the opcode? Because this is like 32 bits and then we have push. Shit. It's like totally wasted. And you know what? It doesn't matter. We just use push and then store 4 bytes and then every opcode will be just 1 byte. F this. I'm wondering if we use like push, if we can use like 16 opcodes. Nah, 16 opcodes will be... You can't tease me with the USB disconnecting sounds. How many different opcodes do we have now? That's 1, 2, 3, 4, 5, 6, 7. If we have 16, we can, if we limit ourselves to 16, then we can use 4 bytes per opcode and and if it's byte for opcode. But how do you store constants? Like if you want, do we use 24-bit integers? Always, yeah, but this 32-bit per instruction is a waste. So imagine that we have 16 opcodes. We use like 4 bits that are 2 opcodes. That's like, I mean, it's complicated. We have, if it's like really compressed, and then you can, if you have like a push, let's say we have a push. If it's a push, then we have an automatic 0 here. If it's on an odd nibble, and then we have basically 32 like byte. Nibble. But you could also have, oops, op. You could also have something like op push byte. Yeah, that's why we use 32 bits. Now we are at CISC region, but this is like really compressed. The only waste would be here, unless you do like op here, and this is basically the opcode that's interpreted after that. But this is going too far. We don't do compressed. We just do that. We just do that. This is how we work. This is how we work. Okay. Code structure. Oh no. This is getting really, really complicated. Okay, the labels will be converted to actual bytes, not like index. Index of the, not index of the line or whatever. It will be an actual byte address. Offsets. Labels. Dave is experimenting. Oh, Dave, you made it already. You need 32 for address. I don't need 64. It's not animated. Yeah, you can do. People do animated stuff. I think. Yeah, we had already shaking and rotating chat windows. I had to filter it a little bit. I'm not sure if it might not support everything, but that looks pink. This code. And then we have how do we execute? Okay. Execute just runs executes one opcode. And then we need a list, like index lists. We might want to change it, but execute will basically take the opcode. So let op be this code that needs to be uint int 8 array. This code instruction pointer, this IP plus plus if op so what is love? 0. No. Do we do this codes opcodes equals store is push. I hope that works. Opcode push. That should work. Shouldn't it work like that? Yeah, that should work as well. If opcode like this, opcodes. Oh, wait. No. This opcodes. OP push. That will be a 32-bit integer now. So we have let value be this opcode or this opcode. Yeah, you need to see something. Shift 8. Little endian. Peeps. The only thing that matters. 24. And then big endian? No, it's little endian. It's executed like in sequential order, and the lowest significant byte is LSB. So, and then we have basically, I'll just keep it like that. We can make it. Byte order. I don't know. B. Push B. Okay, this is executed, and then we have the other option. Oh yeah, we have this halted. Oh, you know what? Is there a state where it's halted? else, that's easy. This code, no. Next frame. Next frame, you say? No. Here we go. Done. That's the whole interpreter. But there is one thing. Should we stop the execution or should we just wrap around and starts all over again? This, if this IP greater equal than this code this IP equals 0. It starts from the beginning. That's basically it. Okay, we have nothing for new frame. No, I won't reset the stack. You know why? Because you can work with that. Oh no, you will. Oh, you need. Yeah, you are right. That's not good. Yes, yeah, you're right. But empty? Here we go. Okay, that's the whole interpreter. It's Turing complete. Now we start. Not even 10 o'clock and we have a complete interpreter. Dave! We need to ban Dave. That's usually a perk that I need to... At some point I will activate it only for... Oh, wait, you are a supporter. You will get a supporter. You're important. Now create Doom. You just need... Yeah, we need a compiler now. Maybe we should do opcodes. Yeah, this is not good enough. You know why 128? If we store it in a byte, then I want the first bit to indicate and maybe use everything else. Okay, we want and it's not implemented yet, or wait, or XOR not and then we have ink deck is before that. Ink deck arithmetics. Yeah, but I want the order of... I mean, we can use any order. Okay, let's put the ALU. You know what? F this. We will put push as 0. Here we go. Push is 0. Pop. Oop. Oh wait, this needs to be this. Pop. Yeah, here we go. Oh wait. Where's the comparison? This. Yeah. This pop, that's basically the storage operations. This load. This store. Then we have branches. Yeah, I need to reorder it a little bit. Branches, store, load, push pop. Here. Store load. Then we have branches. That's 0 jump, 0 x decrement, increment, not x or yeah, whatever. That needs to go before that everything. Execute. That's LAU. ALU. Okay, let's put the branches. Let's start at 8. This jump, which doesn't exist yet. 9. This jump equal. 10. This jump equal. Jump not. Oh wait, what is jump equal? Compares to? That's too many. Jump 0 and 12 is basically arithmetics as well. I don't know. It might. I have no clue. Huh? The jump equal, you would need something like CMP. Yeah, let's do compare in arithmetics, and then we have equal. Yeah, so let's do that. Let's do one arithmetic, just compare CMP, which will start at 32, and we have basically this and then we have, but what, we don't have flags. We need flags for that. That will be this flags. Wait. Compare. Yeah, I just do flags, whatever. But that's it. That's stateful now. I don't know if I like stateful. I don't like if I like stateful stuff. Because we don't have registers at all except for the flags. Let's think about this first, but yeah. No, XOR. Wait, why is not? Yeah, you need to subtract, but then you need something like clone, like duplicate the latest stake. Because it's the best language. 35, this, not, everything runs in the browser here. Yeah, you can close this. Or not, and then, wait, XOR. XOR. R5, and then not ink deck, and then we have add and sub is coming to that as well. We have no shift yet. Yeah, that's good enough. Interpreter works. Then we need something. Oh, flow control. Wait, flow control. We don't have jump and jump 0. Okay, so flow control. That's easy. Jump 0, and then we need jump. Jump is basically pop address and then this address. That's jump. And if we write like now it feels like it's really with push and jump, not 0, like that. Nine and 10. What was missing? 9 and 10. Yes, we removed them. Yeah, let's make it continuous here, and to add later, like greater. We need greater and equal, and I think we will not use flags. Give me arguments for flags, except for if we want to compare, I would rather do a to operator. Yes, call and read, we can do that. But for now, let's just only run this thing. And there's one thing missing, and that would be oh wait. how do we do it with... So when this runs on the interpreter, we have one execution per time unit. But how do we ensure stuff is reflected? Yes, we need something like the interpreter needs to have the access to the memory to heap, and we have frame buffer. Frame buffer. Oh, I forgot something. No, we don't have transparent frame buffer. But the frame buffer, we need to write that store, and that's heap. So we need to know the address first. If address where was the code? In our address space. Then we have frame buffer, and then we have A minus B. Frame buffer. We don't need this, but we have something like, we can abstract this even more. YAML? What? So if frame buffer, then write it. This needs to be abstracted. So if we have like a memory mapping, we can have a memory mapping there. Memory mapping will be... That was fun, yeah. When I was almost rage quitting the stream. Okay, we have increment and or whatever. So let's quickly implement them. So we have wait, that's B and A. B and A. B and A. Let's keep it correct here in order. Wait, let me just check. Not okay. We can even do, let's leave it like that. That's the interpreter. What do I want? We want higher than and not if equal. Oh, yeah, you're right. Thank you for that. I really want to do the mapping, to do memory map. Okay, let's commit. Does it even work? Wait. Okay, do we have any console? Nothing wrong. Okay, let's commit it so you can play around. Interpreter. Version. Oh, yeah. First interpreter version. Do I stage this like that? Yeah. Changes. Yeah, sync the changes. Now we will be doing like that. Okay, we have button run on click. We will convert everything by hand. Ooh. On click run. Okay. We have, where's the script here? Function, 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 function run. And then we have function frame buffer, which is basically address and RGB. And the frame buffer will be just accessing the pics. But do we have some sort of, how do we set the frequency to run it at? I'm not sure yet. Do we reflect it instantly? So if we set like frame buffer and then we basically, yeah, we can run each frame one, like this, the worst. Okay, I will think about it. That is basically if A is shorter than xres time yres, then do the following, and this will be pigs. Is there a division? Integer division in JS? Or do I really need to math floor it? parse int. Okay, yeah, then I floor it. Okay, that sets the frame buffer. Then rerun it, and then we do running. We need initialize let interpreter be 0. And then the run will be basically interpreter new in, is it lowercase? Shit. No, it's not. Huh? Oh no. Frame buffer, and then we have code. Run, and then we have request animation frame, and this will be, we just do every single if interpreter, then interpreter dot, why doesn't it, what is this? Execute. Execute. It will do one step and that's it. Run. We don't have a stop, huh? Run, stop. Let's do a stop button. Stop. Stop. Or halt. No. Halt, stehen bleiben. Yeah, let's do halt. It's a German thing here. Oh, it was quick. Halt. You know how easy it is? Interpreter equals 0, and that's it. That's how it stopped. Bam. Done. Now we need to compile the code. Oh shit. If statement without curly braces is wild. It's only one, what? It's only like one line, isn't it? What? Do you think it's dangerous? Oh, you get used to it. At least I do, and then I debug for hours. Okay. How do we compile, peeps? We need the same thing here. Let's do compiler. Compiler and do it right from the beginning. Ah shit. Lexa? What is a Lexa? Oh, variable names. Nah, that will be done easily. Huh? That code already does like fills the complete frame. Bunch of ifs. And then copy paste some subtrees of ifs. Constructor, and then we have Yes, I will just let me do it. Let me do it. Code text. Let's call it text here. And then we have something like opcodes. And we will have the reverse table. No. Yeah, we can do that, but we will do yikes up. Yeah. We should reverse that. That's obnoxious, huh? Watching that. We can probably at the end use the same list here and then fetch the function name in that here. So I will keep it like that. Oh shit, forgot the comma. So we can do like reverse key value opcodes and then basically text. Let's start with const lines text split separator string will be here. That's it. And we need like const. Wait, that's just one huge. We don't need that. We will just run it here. Compile. It shouldn't start like text. It just initializes and then does like compilation stuff. I don't want this here. This is just the opcodes and we don't need anything else there. Const return code. Yes. No, jumps don't have that anymore. The CPU didn't pay attention. We pushed the address. This push. Huh? Wait a second. The only opcode having? Why not change your opcodes table to push? Yes, we could do that. But I need the bytecode anyways, so it can do. The Shipu, the only opcode is actually push. It's 0. I know. That's why I thought, okay, if I use like 128, like the highest significant bit of the first byte, if this is push, then I can use the other 7 bits because I don't need 256 different opcodes. So that's what I was thinking. I can maybe use part of that byte as data as well, but yeah, I'm still missing a bit. So I don't know. It could be, oh, okay, if you push, that's the sign bit, but that's too complicated. If you push like this one, if you have the sign bit set, you just add another opcode after that negates the value. Yeah, I want, because we don't have floating point numbers and we want fixed point arithmetics in the games. You want 3D games. People love that. People want that. Let's do that. Since the RISC is 32 bits and can run it almost natively, that will be in the megahertz range, because you have like interpreting one opcode is like four instructions or 5 instructions, including a branch or whatever. It's and if you have like 48 megahertz, you can run it in compile optimization. Yeah. Function first, peeps. JIT. What JIT? Just in time. Later. We do everything. You can. We have 3 hours, 3.5 hours passed, and we don't have even like an IDE implemented completely and a language developed completely. So let's finish that. We have the interpreter. We have some code. We have it's Turing complete, I believe. We have a runtime environment, but still we need to compile to bytecode. And if we have the bytecode, then we can just convert this interpreter to C++ and put it on any device. This will be it. An optical wireless upload I'm still waiting for. Yeah. We can do a night shift if you want, but then you have to stay up all the time. I will stay up longer than you, I believe. You probably have to work tomorrow. New. Is it? Shit, I don't know. Fuck. Is a new int 8 array. Is this like of fixed length? It's not, is it? No, it's not. No, it's not IR. We have a light, like an LDR on the device here. There is an LDR and we want to flicker the screen to upload it. But it's basically like IR. Nope, because the address or the object address doesn't change only the contents of the int array. As far as I know, I don't know. Console log and then lines. Yeah. Polyfuse. Oh wait, we need the compiler to be in the IDE here. Let compiler be new compiler. Yeah. Okay, let's not run it completely. Wait, lock. Pop, pop, pop. Run. Const code. Compiler compile, and then text will be basically everything comes together. Query selector, query selector, text area, text area. Is it value? We will see. We don't need to run it for now, but we can. It's tabs on stack memory. Okay, I'm not proficient in 25 lines. We need to remove the white spaces. So truncate, not trunk. What is it? No. Trim. Trim, is it? Yeah, that's trim. Can I trim trim all? How do I do for each line? There is like a for each and then promise whatever, or for each element. Ooh, shit. Line is a string. Trim. Yeah, it won't change it. No, it's true. No, it doesn't do that. Yeah, that won't do it, because that creates a new string. We need to iterate through the whole for there is like an S for each with S, but I will just count through the whole lines. Lines. We also need labels. That's yes. There is like this tuple or something. Okay, now we need to lines I trim. Okay. Wait, lines I. Okay, there are still tabs. And then we will push, so starts with, and then we need to find, we need to find that here. Okay, so we do something like that. Let line be that. Oh wait, that basically we can do everything here. Let's see if index, no, not index of, find. Yeah, it's index of, but is it? Ah, I got the fly. Die, you fly. No flies are accepted in my lab. Index of, search them, yeah. My was it substring? No, what is it? String? No, shit. I always forget. It's not splice, it's slice. Slice, splice, slice. Nope. Substring. Yeah. Substring. One, two, substring two. Okay. It's so strange. Ah. Oh yeah, let's do that. So we remove all comments. Can we do different now? We use these comments, but usually we would use a semicolon for comments in assembler. So, let's see. Tap, 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 tap. We can trim it. Substring trim. It's getting readable. Ah. Yeah. Oh, come on. Mark is playing games and Huh? Steam. Yeah, I'm not proficient in regex, I have to admit. Can I kill Steam? Hey, Sion! Yeah, you missed a lot of things. We developed a system. I'm killing Steam now. Service. Okay, I killed Steam. We developed a system, wrote an IDE, an interpreter, runtime environment, coding language, and assembler language, and now we're writing the compiler for it. A system. Okay, we have pop, and the last one is nothing, basically. There is like a new line. Yeah. Okay, so we have push. We are almost there. Ferret, paragraph, what? Dog. Rico. All big words in bitluni's versions. Yeah. Like always. Still impressed? Yeah. We are almost there. You couldn't believe that on one stream you can basically do what, like, as the foundation of, let's say, a software hardware company at some point. In the 70s maybe. Just an example. Yeah, regex, I know that, but I can't. I don't know. bitluni Incorporated, yes. We don't have multi-line comments though. I won't support that. You know what? I have an idea. Yeah, let's do this. C2 and then no. C const C C1 is that's my regex for you. Here. Oh yeah. We prefer that. So does it still work? Yeah, it's still working. Nice. Okay, so let's tokenize it. Let's find colons. Or should we? No. Should we accept white spaces? Or we just take the first token? There is, I just copy the code here. Yeah, I know. But we will do like line. We will just get the token and then check if it's a label after that. And then we can also do like an error. We don't have a console in our IDE. We don't have a console to display errors yet. So found tokens, ignored spaces, comments, and then fed that to the tokenizer. Yeah, you can do that. Token. Let's see what it does. Store push T. Yeah, there is the tab. It doesn't know. Hey, what? Nah, that's dot. That's replace. Const regex. Okay, so I will use basically, no, but I want also this, not only tabs, I want also white spaces, so oh no, wait. That's white space. No, but not in between. If you have push, push has like a... Can I do T like that? No. I want the first, no. I just want the first word. Or does it the G? Ah, yeah, here we go. But here I have a space. Push, push. Why do I have a space? Oh, we have an extra space here. Yes! YAML for you. That's cool. Okay. So, how do we do this? We do something like that, probably. Now, or this. Split. Yeah, but split doesn't clear it. I think that could be easier to... Look at that. I'm not proficient in regex and I own you in regex. Here we go, peeps. Nice. Okay, we have still clear lines. And then we now need to find out Yes, I am. So do we accept tokens where we have something like that, like say label X and then space and no. Labels have to be connected. Okay? Yeah. What? Ship it. It's getting late. Okay. So token. We need more data. if token length -1. Does it work with like -1? Is this the last byte of the string? Yeah, but we won't like nobody will understand this. I think that's like a specialty of JavaScript and probably PHP as well, that indices wrap around or something like that. I don't know, in arrays? Not sure. Okay, equals boop 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 boop. Then we have a label. Okay. We have const labels. Oh shit, we can have forward labels. Oh no! Yeah, we need to tokenize first and then shoot. Oh. Okay, let's take care to do forward labels later, okay? Oh, damn. Yeah. To do forward levels. Okay, labels. Keys. Yeah, I want to do that. The Shipu. You can, I mean, reverse Polish notation, yes. Oh, wait, yeah. Yes, but we can still... We just need a second pass, that's all. Yeah, reverse Polish notation, etc. can do, but then it's also, I mean, this is, people are interfering. This is a low level. The bytecode is the lowest level. No, the bytecode is like the lowest in this sphere. Then we have like the actual hardware. So the lowest level of the abstraction layer is the bytecode. Then we have the assembly, which is basically the broken down, like next abstraction layer, which is human readable. And then you can put on top of that any reverse Polish notation you want, or any way you want to do it. You can always like write like a C++ compiler that generates the bytecode or generates the assembly and then the bytecode. So it's up to you, and that's just syntax. If you want to write like the whole code in reverse Polish, you can make it shorter, but then you are just converging towards Python or C++. You will get in trouble with labels at some point, so you still need new lines. Let's just keep it simple. So if you want to develop like a working interpreter with a new language, let's not make it complicated. Function first. Then we can do a high-level language at a later stage. Like a C++, GCC. We just need to plug into GCC our instruction set here, and then we good. Abolish labels. Okay. If token in labels, already defined console error or console. No, I was reading something. Console error label already defined, and then last token. Line. Oh, we have a proper output here. Compile and then console. Yeah, but no. Console and then console error, and then we just pass console. We can just replace it at some point. Compiler, query selected value, console. Okay. So we can do that. Error and then line, and then just add E here. I. Otherwise, we do labels. Pop, beep, pop, pop. You can have also an empty label, just just like that. Labels, and then have I have an idea. We need also do a label here, and we just need token substring token length -1 -1. So we just keep the label. I have an idea. We have, if we find like a push and then a label that we don't know yet, then we just take then we just add this to a list, and the address, we will write a 0 there, and then afterwards, if we find the label, we will just replace all the instances that we have. So const labels label instances is basically here. Label instances. What is this? Why is this not used or what? Label instances. And then we will just add label instances here. Labels equals code let IP equals 0, and then we have labels equals IP. That's the instruction pointer. And then if label in label instances, we will do the following. Replace, we have the forward labels here. For let j equals 0, j is shorter than label instances. Oh, that's the syntax error. So we will have a clear syntax here. This will be basically everything. We can do like extra checks. We will ignore everything after the colon. So basically that's, you mean like a label needs to be a separate line. Let's keep it like that. Or do you want to have the label in the same line? We can do that. So you can have a label in the same line and then just continue with the line here. So basically the line will be yes. Yes, basically yes. J++. And then, okay, don't distract me. We need to finalize this. And also, this is the token substring label. But we also need, what? Good night, Shipu. Oh yeah, where is it? Label, sorry. IP, that's just setting the address. Then we have the line. We have trimmed everything. after the token. Wait. Set trim. What was this doing here? It just keeps the first word. Yeah, that's the token. But we would need to continue with the token. So basically what we do is here, we need the line, we need to truncate the line afterwards. So let's keep that in mind here. So the line is basically the new line is substring token length substring token length, no wait, token length, it starts from there and then we trim everything. So we skip all the labels and continue with the remaining line. And then we have something like, and then we need also, so let, because we need to do this again, we can have a label in the same line as an instruction. I accept that. And then we just continue with the token here. Lines equals token. And then we need to replace the instances. So this will be right int. Hey! Why? Hey! I just wanted to close the parentheses. What? This is stupid. So, alright. This will be code. And then we have the integer will be basically IP. And we write at the address, which is label instances label, and then we have J. And then we have the right integer, which is here. Int. And that needs to have array or array index and value. So we can do this. Let's call it by its name. 32. Okay, so AI equals, I just don't want to so much copy paste. I hope the array is extended automatically. Could be index out of bounds in Java. Do we need to store 32 bits for... Yeah, we store 32 bits, whatever. Don't care. That's basically, oh, 16. Thanks for mentioning. Probably someone just writing. Okay, so we do all the... Hey, Michael! Can we remove... Oh, we can just ignore. We don't even need to remove it. We just write all the references that were back there. That were used before. So here we go. Let's see if the labels are gone. Boom. Yes, labels are gone. Oops, you can see. So X and Y labels are gone. Now I will try something new that should be supported. So push 15. I hope that this still works. So do we have push push, store push push push, push push, store push, push push, store push, push push? Why do we have like two new lines here? Oh yeah, there is one new line. But where is this one coming from? Push load, new line. Where is this new line coming from? I do X. Oh wait, that's wrong. That needs to be, X needs to be here. And this is Y. Oops. I store. Oh, okay. There was some sort of push, 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 load, push, 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 loading, store. Okay, that works. Why is this one marked but not this one? Thanks. Thanks, the 80. Okay, so we can even like change our example code to be like a few lines shorter. Like that. Okay, that's accepted. And then we need to finally convert the tokens. The labels will be still tough since we need to check for integers or hexadecimal. 0x, yeah, we'll find a way. Okay, now we have if token length Okay, so if we have a token at all, or yeah, we check that first. Then if token in opcodes in this opcodes, then append int 8, which will be array, and then v, and then append int 32. Hey, xzy. You're also coding? Yeah. We are meta coding today. Basically, push. Writing an interpreter that runs in an interpreter. Okay, V and 255, and then here. Oh, really? That's cool. How many, like, how big, how capable is it? If token in opcodes, we do the following. If token in opcodes, we take append int 8 Oh, we need also return. Wait, instruction pointer. We don't need an instruction pointer. There is no instruction pointer. This is basically code length. Sweet. Oh. This is so cool. So easy. Predicting words? What? Build a data set, a model that recognizer. Ah, that's cool. I mean, that's you will be a successful in the future world. Like, there will be no demand in coders or whatever, except for the ones that make the models that replace coders. Yeah, this opcodes, and then token. So this is the first token. If not else something else happened. We have the first token. ChatGPT GPT-2? Ah, okay. very, very sophisticated. We are way simpler here. First token needs to be opcode. Yet could be also data like data with implicit push. And then else console error unknown opcode and then token. If we need to have another function for that shit, or we do if token, oh, let's say if opcode's token is 0. I'm writing a complete IDE with an interpreter in JavaScript with a small language that we can write like mini games for this mini console here, and it will have like a transmission, flicker transmission for the light detecting resistor here on that device. So this is a little bit crazy right now. Yeah. Okay, there is something missing. What is missing here? 59. Yeah. There's what is missing? This append. This. Huh? This oh, code. There is something missing here. Code. This opcode. Let's do that first. Now we need to interpret the token. So either we use integers here. The next token. So line will be. It's a little bit stupid because that's not like recursive, and we need like to tokenize it or whatever. But I will do it like this way. The compiler is quite big already. 100 lines of code. Oh man. For an assembler. Still doesn't like it. What is going? Ah, here. Okay, run. Unknown opcode push. What? Huh? Oh. we need to reverse invert. That won't work. Yeah. They break it. What did happen? What? Doesn't like it. The invert. Yeah, okay. So, okay, let's do oh, what? Let's take that. Ah, there is your key value thing. Okay. I like new lines. Huh? What's happening? Hey, David. Something's off here. Okay, let's run it. Huh? Why did it break? What happened? Text is undefined. Yeah, text is undefined because the page disappeared. What happened here? Huh? Did I break the console now? Text compile, text console. What is going on? Okay, I load constructor. Oh! What? It just disappears. Something's off with... Let me dispose and go live again. What's going on? Swap is not defined. Ah, yeah, okay. That's the issue. Okay, so let's do swap here. Const opcodes swap, and then this is opcodes. And then we will just take it here without this and this. Okay. What is it now? is it now? Huh? Oh, this. Yeah, that's how we define it. Okay. Yeah, I admit. What's again? What is going on? Store. Okay. Here. Push undefined. A append int 8. So Devil, your own assembly? Yeah. Buffer. A is uint array. Oh, there is no push in uint arrays. Shit. You know what? Then let's leave it like that and then convert it to return new uint array and then code, and this will be it. Yeah, unfortunate. I thought it would be possible to append to buffer, but it's basically a buffer. All right, no errors. You can disable the camera. We don't see anything anyway. So these are the, now is only one thing. There's only one thing missing in our stuff, and that's taking the second token and storing it. And the problem is we also need to support those here, which is, I need to use a tab here. Let me use a tab here. Boom. I enjoy this coding session today so much. Okay, XY, and then we will just check if it's a number. So that's an interpreter token append int. Okay, if it's a push, then we need to get this, and then we get like second token or const token 2, oopala, token 2 equals wait. We need to trim the line. Then we get a new token. That's basically the next token. Token 2. Then we can do const int no, that's like the value, and then this get parse int. Oof. It will be hard. And 32. Let's do this and use token 2. And we need to check if there is some extra code. Warning, there is some extra or an error. I don't know if we do warning or errors here. Also, we do this. Length, then extra. No, wait, yeah. That can be done here. That's the opcode. And then we can do if line length, then we have token 2 length. Yeah, no, we will. Oh yeah, token 2. Yeah, you're paying attention, dude. No, this is, oh shit, token. No, we take it like that because we have a new token and we trim it again. So, and then we check. Extra runs, and we do console error. Extra characters in line. Okay, extra characters, and then we have line plus inline plus I. Here we go, and we have unknown opcode, and then that's in line, and then we need plus I. It's I. We have even some errors here already, so some safety checks. And this is token needs to go away. And now we need to implement parse. And then if v undefined, so v comes here. If v undefined, then we have a label else v, and then let's hope there is something infinite. No, let's hope v works here. Code and then label token that's cool. Let's start depth first. Parse int 32. parse int 32. That's text, and then if the is this really a no, is it? It actually is. Okay. So hexadecimal. We don't do like with this H at the end. I don't care. We can extend this at some point. Return, and then we do t substring 2 to parse int parse parse int 32 parse and wait, was this parse int? Yeah. No, wait, parse int is oh, that's native. Okay. Else let's support binaries as well, but not octal. Who uses octal? Go away. To turn parse int t. Oh, can start a new token can start with yeah, but you know what? Fuck it. Usually you wouldn't accept an integer as a token. So if we get anything this parse int, then we need to drop an arrow here. Then do this. Console error. Label can't be a number. Okay. and then we have basically label, and then we will store the label. Either we find it directly, which is we can simplify it with replacing all the labels at the end. Wait. This is cool. Instead of this will be way less code. For labels I++. So we just do it at the end. We just replace it here, and we will just add every new label that's used somewhere as an instance. So we can do it like that. Const label equals labels I, and then we just take the label instances and not write IP. Yeah. Huh? Where's the IP? What's now? We use labels I. Oh, wait. No, we can't do it like that. For each JS, for each object. For in. Yeah. For const label in labels. This is it. And then we have like that. For, and then we have, don't need all this stuff. And this is the address. Oops. Labels and then label. Okay, so now we only need to undefine, and then we will just add the label instance. So we almost done. And it's not 12 o'clock. Interpreter will be running in a few minutes. I hope so, at least. If token in label instances, then do the following. Else label instances token equals this. Oh no, equals code. Yeah, code length. Nice. Wait, here. This is right. Label instances and then label instance token push. Wow, this is so cool. And then code length will be just appended here. One pass compiler. Okay, how big is the compiler? Without this lookup table here, 20 to 120 lines of code is the compiler that generates the bytecode. Shall we? I don't know. Foo. What do we do now? Run it, huh? Okay, it's loaded. Let's run. Okay. What's going on here? Parse int not. Oh yeah, there needs to be a this parse int. That's here. Without error checks, it would be 100 lines of compiler. Bam. Oh, look at that. That's funny. It actually attached the last token. Label can't be a number. Oh shit. Parse int doesn't return undefined. Wait. Let me check the definition of return value. Oh, not a number. Okay. Okay, this is not a number. Parse int none and parse int. Oops. Is it? Johnny, we are almost there, yes. Okay. What? It's not a number. Label can't be a number. Let me check again. Oh wait. Oh, maybe. Oh no, wait. Parse int label. Yeah, what is the return value here? Okay, we need to step through and see what's happening. Or I'm not returning something properly here. Oh wait, am I returning? No, parse int. Parse int radix, parse int t. Should be a nan. Or is nan undefined and we need to use math nan? What is it? Okay, let's step in. Return value is a none. Huh? It is a none. Working with not a number is really... What is not a number here? None. Oh, Kaspar, please don't go. Help me. Why can I compare with none? Is none. Okay. I think it's is none. Is none JS. We are almost there. Yeah, we are almost there. You can't compare with not a number. It's how do you compare? Okay, yeah, I got it. If is none, and then do that. And then we have also if not is none. Where's the none here? Is none. Go brushing your teeth and come back, and then it will be running. It will fill the frame buffer just for you. And TTS has died somehow. What's going on? Okay, no errors. Now we need to run it. Now we need to run it. We'll see what happens. Does it run first try? I'm eager to find out. Nope. It stops at the pop here. Store this pop undefined. Huh? What? Store this. There is pop. Okay, let's check. Run away. Shit. Why is bitluni not functioning? It's too late, too old, is my TTS gone or? Huh? I can't hear him. What? Is my headphone died or what is going on? Shit. Lines. They're not there. Yeah, I can solve this right now. I rather want to solve this issue here. So what's the matter? What's the matter, baby? Huh? What? Huh? So sources. This pop, it's there. So pop is not a function. So there must be something wrong with the code. Why is this pop not a function even though it highlighted it? Store, push. This stack push V. Pop. I don't get it. Okay, let me run it again and step through. Okay. Execute. Oh, I have an idea what the issue is. I'm using another object here. Wait, here. The opcodes is a different object. So that might be the issue. What is going on here? Okay, push. This will be, yeah, this is opcodes and not this is this object. Okay, so I will do that. I will change that. How was that? I know. Runtime binding. Yeah, I need to. I will do a workaround for that. Just for now, okay? So we will take the opcode and execute. Wait, interpreter, execute. We'll take the opcode there. Execute. Opcodes. This push, whatever. Yeah, that's why. Otherwise, OP this opcode. OP. How do I use? Binding. Bind this in class. Yeah, I will just run it like that. Opala. Opala. Let's see if that helps. Otherwise, I need to run the binding. Huh? Where is my interpreter there? Okay. Still, this undefined. What's? Oh yeah, bind. Does it work? JS call, okay. Okay, this is this. So we can still do this. Call this opcodes of OP. So, and this will be, yeah, we can do this object here. That's binded to call to the current one, I believe. I can't see the chat window anymore. Nothing is running here. Hey Max, thank you for the donation. My TTS is broken. I have no clue what's going on. So sad. Not even my headphones want to connect right now. I don't know what's going on. Yeah, but we're almost there. Run it. This opcodes. There is one this. Last this for today. Here we go. Run it. No. Undefined. Is it prototype? Class prototype or what? Function prototype. Yeah, but I need to do this in. It's strange. I know I had like it's a long time ago that I was coding object oriented in TypeScript or ECMAScript. No, is it? It's what is it doing? What is it doing? Can't see shit. Oh wait, no. Does it run? What does it do? Doesn't run code. I have no clue if it runs code. Okay, we need to step through each of the executes to see what's happening here. Okay, that doesn't matter. Okay, let's run it. What does it do? Why did it stop? Okay. Opcode is 0, which is correct because we have a push. V is 0, which is correct. So, oh, what? This push? This is stack. No, this push is, oh yeah. Wait, where's our stack? Is our stack now? Stack has one element 0. Okay, that's correct. Next opcode. Also, push. Looks like an address. I have no clue if this is correct. H opcode 0. Oh, that's not correct. Why is this 0? Oh no. Show me the code. Nah. Oh, this is funny because we have some code here, but everything is empty except for, I don't know. a few bytes. Okay. Joshua, thank you very much. Okay, so we store the wrong opcodes during compile time. Okay, we store the wrong opcodes. Compile, append, opcodes token, and the code. This is, we have to verify if what's happening here. Token opcodes push, otherwise opcode token. Okay, let me check this one. Push. Push is 0. Okay. Append 8. A push V. That's correct. Yeah. The token is address. It's not a number. Append code. Code is now 4. That's correct. Yeah, that doesn't matter. Okay. In opcodes, token is push again. Okay, we have the same issue here. Nice. And then token is store. Opcode store should be 3. Code, we have the 3. Line substring. Okay, code. Now we get 0 again. Is the token push? Yes, it's push. 8. Now we have push again. Now we have push again. So many pushes. Load. Okay. Load is 2. I think we have a misalignment somewhere. Here we go. Token push. Token push. Okay, we have so many pushes. Load code. It looks like genuine code. I have no clue what was going on with the other one. Okay, so let's go on here. We have code. Oh, that was completely overwritten, was it? No, 0, 1, 2, 3, 4. And we have 0. Then we have the address. And we have... Wait. That is 10. 10, that's correct. Then we have 3. So let's do it. IP. That's 5. That's correct. 10. Opcode should be OP3. It's not push. Store. Okay, we had a store opcode 0 again. Yeah. 8 0 again. Zero again, then we get a load. 2, which is a load. Huh? Did it load? What is on the stack? What did it load? Okay, we have push, 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 push. Oh, this is not correct. Where is my load? This push, this heap, this pop. Okay, we need to check that. Increment, we need also to check that, and increment and decrement. We'll just check all the jump not 0. That's also 1. And store. Okay. Yeah, this is all. OP6. Huh? 36. 36 is increment. Okay, that doesn't work. My call doesn't work. Compiler works, but call, dereferenced call, or not dereferenced, the stupid. person. Okay, let's see. Oh, okay. I don't pass the this to the call. So I do this opcodes op call, and that's it. Person want this. Huh? This is it. It's all a bit strange syntax here. Oh yes. Yes. Okay, peeps. It's happening. It's happening. We're running our codes. Oh no. What opcode was that? Some opcode was broken, but we were almost there. It was running. Cannot read properties from undefined reading call. What were you running? I think the some jump address might be wrong. Yeah. Okay, let's clean up some shit. And I think console log lines. Let's remove that. It's only confusing. Too many lines in this code already. Execute, and then we will just display the line numbers here, or the opcode, or the address. Console log this IP. That's it. Zero 510. And then what's the issue? 3 store. Oh yeah. $51 0 5 10 11 16 21 26 27. Okay, push 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 push, do something. Okay, this was store, or we can just write the opcode there. We could even drop in. like that. OP. Function name in JS. Yeah, it's name. Okay. That's opcodes OP name. Okay, that's my debug output now. Okay, now we're opcode 11. That is probably just the wrong address. Eleven is not even there. Push decrement. Okay, we have increment. So we were here, then we stored, and we decrement, and then we push, and then we jump not 0. And that's where he's confused. Okay, let's check 8, 9, 10 and 8, 9, 10. Wait. Huh? What was the opcode? 11. Huh? What is IP 52? Code 52. This is completely broken. $36, $16. Okay, wait. There's something off. P is 11 and IP is 51. 51. Before that, we're pushing $36, $3, $37. Let me put the list here. So we have 36 is increment, 33 is increment, then we have store, that's correct, 37 is decrement, and we have push, jump not 0, 16 is, where is this coming from? No, what? Oh no, this is storing the 16 again. Huh? What? Push. Okay, and 37 is the decrement. Then we have push X. Push X is 16 is the offset, which is basically here. This is correct. Offset. And then we have 11. Where is the 11 coming from? Oh wait! There is something off here. $11 is the address here. $15 is so 15. What is 15? That's store. Y3. Why does it push 15 and 15 here? Oh, there is something off. I have a copy paste error somewhere. And storing the integer. No, append. Right integer is also right. This is really strange. Push 16. Okay, I make a decoder. I make a decoder for the codes. I need to do that. Otherwise I won't be able to see where it breaks. Compile and then decompile. decompile. Yeah. Decompile. And that will be a quick one. Code. While let I equal 0. Code length. And then let text be GitHub for Dummies. What is that? Did my chat die? Everything died. Okay. Or we drop it in the console. Console log, and then we do that. That's quite simple code. Yeah. So this opcodes code I console log this line equals yeah, but this is like 5 lines of code. Line const o code. Okay. NSA? Really? Why is bitluni working all of a sudden? I don't know. We are back online. We are back on track, peeps. If op o equals 0, then it's push. So we need to add basically the address, which will be to string. Okay, to string 16, and then we will do basically code I++ or wait, and then let's do that. Okay, console log. That's it. Decompile code. I'll just. It's so simple. 5 lines of code. 5 lines of code. Compiler. Decompile code. That's it. It should drop the decompiled version in the console and undefined. Oh, endless loop. Plus, here we go. Missing that one. Oh, it's that. Shit. Need to pause it. Oh no, it's that. Okay. Okay, so what do we have? Push 0, push a store, push. Yeah, that's broken already. Yeah, indefinitely. Oh, I don't like it that it put a push 0, push 0. What is this? Is like broken. I think what is going on here? Why does it? Okay, that's basically storing the bytes twice. The lowest significant byte. Lowest significant byte is copied. That's why it's. Huh? That's on append. Yes, that's on append. Append in 32. Huh? That is correct. So it needs to be parse in 32. Could be broken for whatever reason. Huh? No. Okay, I'm confused. I'm confused why this. The lowest byte is just copied again, and then we have strange behavior. We have the load. Here, then we have 80, and that's repeated again. Then we have a push twice, And we have a load, increment, store, decrement, push 10. Then we have an undefined. And push 0. Nah, after that everything is mangled. This is awkward. Okay, let's debug where the integer is stored, the 32 integer. That's basically here. That's the instance token and append integer. This is where it breaks. Okay, code 0. Okay, yeah, there's nothing we can see here. Also nothing we can see here. Now it stores 15. Let's see. We have 0, 3, 0. $15, 0. Oh, 32. Oh shit, I didn't see it. Nobody saw it. Damn. Okay, that's one error, but there's still another one with the jump. Let's see what it spits out. Okay, this is now correct. Correct. Increment push 10 undefined. Push 10. Decrement, and then we have decrement, push, and then not jump. Okay, I will check if we overwrite now. Yeah, it's rotating. It was just rotating. Let's not replace the labels and see if our method of placing the label addresses, if that's overwriting our code. That could be one of the errors. I hate that this run button is... Oy, 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 oy. Yeah, this is now... Yeah, but forget it. Okay. Store... decrement push. Why is this? And then you have a 16 again. No, this is 10. After the push we have a 10. Let me check with the opcodes. Decrement, jump, not push. Jump, not 0. Then we have a 1. Pop. Then we have was 37. 37 is decrement again. So this push doesn't have, oh, it has a label, but we don't store anything. Ah, we don't have the placeholder. Okay, that's the issue. Found the issue. We need to store the 0 for the placeholder. We moved the whole code, but that's bad. So we do this here. Label instances, yeah. Label instances, token, and then we need to also store this append, and this was be basically 0. Here we go, that's it. We got it. That's it. Boom. No, it's not drawing anything, but let's see if decrement, push 10, jump not 0, pop, decrement, push B, which is 12, jump not 0, pop. Pop twice. And then the code runs. And runs and runs and runs and runs and runs and runs and okay, code runs, but we don't see an effect on the screen. Okay, let me remove the thingy here, and then let's see what the debug output on what's happening. And that's the debug output. And we should be able to step through it. Okay, code is correct. Code is correct. That is 10. That would be wait. The first one is 10, store 11. Oh yeah, 11. Yeah, you're right. B. So it should jump to B. That's correct. And then we have another, which is 10, which is A. So this is this loop. B. Wait. Huh? This should be 10. Pop, decrement, push, jump nodes 10, B. Oh, that's 16. Oh, because that's push 15. So in 11 plus 5 is 16. Oh yeah, no, that's correct. That's the inner loop and that's the outer loop. Okay, now let's see where we can check what's going on the stack or whatever. So let's stop it here. It's running already. It's broken. And add the watch list, and this will be stack. This stack. Let's see. -1? Why is this -1? 16. Why is this -1? Why do we have... Let's see what happens here. 16 -1. Something is off. Okay. It decrements. Okay, let's run it again. Okay, stack. Where's my stack? Yeah. Oop. $15, $16. Okay, that's our counters. So we stored 15 and 16. Then we should store 0. Then we load from 0, which is also 0. That's all right. Why do we load it from 0? What is there? No, wait, store didn't work. Or load didn't work. Something didn't work because we should have... Oh no, wait, load didn't execute yet, or what is it? 128. Huh? What? What is going on? Okay. Okay, now this should be stored in our heap. Wait, that's the compiler. Heap. Nope. Nothing is stored. Okay. Okay, let's see. That's a good one. What is going on? What is this stack? What is going on here? Huh? That's so strange. And why do I need to see this stupid box every single time I open this? It should just fuck off. Okay, let's reload the whole shenanigans here and see what is stored. Okay, that's stored. That's the value, that's the address. Heap. Oh no! Yeah, that's an issue. We need to use the address there. Store. Yeah. Okay, store is broken. Store was broken. Okay, heap should have the address now. Okay. Increment store. Now I'm curious. Oh wow. Oh, I see a problem. I see a problem. The code is missing something here. We load RGB. We load the address. Load. Oh no. Store, increment, store, and there is it missing. We should also write to the graphics memory. That never happens. And then the stack is corrupted. Okay. Nobody saw that. So what happens is we push that, we load the address, it's on the stack. We push that, we store it. There is the store missing. That's missing. And then we push 0. Push 0 load. Load the address again. Increment it. Store it. Decrement. Yeah. There was one thing missing. But still store, because oh wait, you're right. Store. Broken code. That never compiled. Okay, run it. It writes to the frame buffer. Moment of truth. Moment of truth. Clip it. Oh. Oh no. It wrote just black. Why is it black? What is the value? 128. Oh, I forgot the value in the IDE. Okay, peeps, this is happening. I'm recording it. I'm recording it because this is the last bug, and the interpreter will work. So this is basically loop frame buffer. We need the frame buffer. X, Y, and this is RGB. And now it should fill the complete frame buffer with squares. Yes, the code is running! The code is running! One opcode per frame. Yoo-hoo! It works! Ah, this is cool. Hey Michael, yes, yes, yes. I don't know what happens. It should just restart at the beginning, but the heap isn't reset. So it will break. No, it will just clip. Okay, I have an... we need a new heap. Stop recording. I will fix a few things and then we will... More colors. And we can run it like multiple times per instructions per frame. We can just okay, let's make it fast. Let's make it fast. Color cycling plus interpreter. Oh, now we demo coding here. Graphics demos. Okay, so the interpreter needs to reset the heap when it restarts. Does it need to reset the heap? No, it doesn't. We can do... I have an idea. How about we take the pixel, the heap stays the same. In the code we have in the beginning, we write this address, we push it to 0. What we can do now is we can just load the address, load, and we need to push. Why is this? Why does this move? Don't move. Instead of pushing that, we will just push the address 0x0004. Then we will load it. We will load it again. No, push, load, load, then increment, then that's stupid. Push and store. No, we need to push it twice. Load. Push it twice. Increment store. So this will increase, the color will increase, and then we don't need to push anymore because we loaded it before, did we? Yeah, I hope so. We'll see. Stack is really mad now. Okay. Load the address. Then push. Load the current pixel color. Then push it. Push it. No, we need another load and then increment. Okay. Oh, I can just change it here. And I need to oh, yeah, it's still running. I need to get, so this load. So this loads here, then it increments, then it stores again. I think I can change the order. Address last, because wait, isn't that address last? No, this is value last. I'm wondering if address should be last. That makes it easier. Yeah, I will rewrite this. I think I will rewrite the order of store and load, because now we need like to store the address multiple times, and we should just, the value that we are working with should be just the top of the stack, and then if you need to like operate with the memory, we put the address on, operate, and be good. I don't know what's the best. Oh yeah, it's working. It's incrementing. But it's slow. Okay, let me run it faster. Let me run it faster. Animation frame execute, and we can just do for let I equals 0, and then we do like I is thousands of instructions. 1000. No, let's do nerdy way. This is it. And that should even loop around. Let's see. Does it change, or is the heap persistent? Does it still run? And then you need to write a whole game in assembly. held. Yeah, I need to see what's happening with the heap if it restarts. Yeah, we need something, or we just take another compiler, a basic compiler or a C compiler that writes assembly, and then we can basically convert to assembly, to our assembly. If something is not implemented in our assembly, we will do it then. Doom splash screen. Yeah. Okay, execute stack. No, heap should be kept. Interesting. Let me run it. Is it broken? What's going on? Ah! Request animation frame is really... it's evil. Nope, it doesn't restart. Okay, interesting. Maybe there is still one bug that my loops don't end here. Forma 32 error, better late than never. What? 32 error? What's 32 error? What is going? Oh, that takes so long. Okay, let me do store here. Store in every pixel. You just break every pixel. Ah, yeah. I should look at the stack now that we wrote a few pixels. Watch. No, this. Oh, wait. The stack is somewhat broken. Huh? Okay, let's run it again. 16. 15, 16. Oh. Okay, we have a bug in the code, I believe. The same amount of pushes and pops. Yes, somewhere, but I don't know where. Pop. It's somewhere here, so load. Or pushing one too many. Okay. Push on stack load. That loads the address for. Then we have push. That loads the pixel value. Then we have a oh yeah. That loads the pixel value. Then we need to load increase. Yeah, that's the one push too many. That's one push too many here. Uh-oh. No, now it's broken. Now we don't have the address. Right. Yeah. Huh? My brain is farting. Okay. So we have the loop counters. Then we push. I take a pen. I don't have a pen. Phew. Okay, let's do that. X, Y, X. Then we have address on the stack. Then we have color on the stack. Then we have, oh wow, then we have the address of the color, let's say D, then we have the color again. Then we increment, so we have, let's say E, then we store it. And we store it and we push load increment store. Huh? Did I miss something? Give me a break. Okay, again. X, Y. Maybe we can see like count it. So in a loop, we are here in the inner loop. We are +1. We are equal +1 equal +1 +1 equal equal -2 -2 +1 +1 equal equal -2 and then decrement. What? Oh yeah, decrement X, then push X, jump not 0, which removes it again. And oh yeah, we are wrong line here. But oh, we are at a better state before. Yeah, here we go. Finally. Okay. Yeah, the labels were in the wrong place. I want to change the order of the address stuff. You know what? The address order is stupid. Yeah. Isn't that cool? I will change the order before I leave the stuff to the people, and we then maybe need a syntax. That's a little bit of work. Let it run. Okay, so now from now on, and I need to give the editor the tab. So blue is coming. It's rotating. Keep tab in text area. So okay, I have that. That's evil code, but alright. So IDE, and then we need to init basically tab rules. Const. What the F? Who codes like that? Count. Why do we need to count? Key code which prevent default start. Yeah, we don't even need these parentheses here. That can be beautified maybe. But I need my tabs. That works. Okay, tabs work. And then now we will change the order of store, which is like that. And then we need to change the code. That's it. It was just the order of the store. What? No way. Okay, so. Shit. Okay, store. Okay, store. Pops address and okay, pushes, then we can do the following. That is easy now. We can reorder everything here. So we can just write pixel frame buffer, then load that's the address on that's the address, but we need to pop load that okay, push load. Okay, we load the value of the current value of the current value of the pixel. Then we don't need that right now. We push the frame buffer and then we store. Then we also load, we load that again. We load again. We can store it. Wait. I don't care about this. Reload, increment, store it. That's basically Okay, and this is basically, we can test that. Yeah, we can do it like that, so there is no confusion. Load RGB value mem. Photo, what does photo say? Store again. Maybe I should rename it or accept it as another one. Yeah, we can add it to the list just with the same code. Okay, this is more readable. Okay, let's do. Okay, store frame buffer address in mem0. That's it, too much text. Pixel lines. Pixel. No. Yeah. Pixel call. Rows calls. Yeah, I know. Now I remove a little bit. Right pixel. Increment. Load. Load frame buffer address from mem0. Okay, and then right pixel. Nice. Increment buffer. Increment frame buffer address. Then we have right pixel. Here we go. Wait, we don't need that. Then we need to increment frame buffer address, and then we need basically this. It's way better than nested stores. Increment RGB color in mem4. 4, which will be 4. Then for later, what is this shit? Okay. Decrement. And that is now consistent because the label address is also second. Oh, that's way better now. Okay. Pushes label why copy paste or what? And then wait, why do I pop twice? I don't need to pop twice. That's even wrong here. Clear Y counter. Okay, found even some bugs. Nice. So many, like the storing the address here. Maybe we should have like a push, a 16-bit push and an 8-bit push or whatever. Like packing a little bit more of okay, I will leave it like that. That looks way nicer. That code looks way nicer. And it runs. Oh, logical. Yes. Now we need some shifts and stuff like that. We don't have add. Should we add more? Okay. You know what? Now I'm hooked. I need to do a few more slide things. No blue still. That I want to change that, okay? Let me add the changes. Commit and sync changes. Now it's up. It's open source. A free assembler. Bitluni assembler. I don't know. Run. Okay, let's do an add, shall we? We have AND or XOR inc deck. We don't have add yet, so let's add. Oh, that will be one of those. That will be add sub Now we just need to extend. And clean up the code a little bit. Because we have okay, we didn't even try XOR and stuff like that. That's it? 2 more opcodes? Just implemented like this? What? Okay. Yeah, we could do like save and load and stuff like that with a thingy, but oh well, I will just you didn't update the method references. Oh yeah, you're right. Are you paying attention, dude? Add and sub. Yeah. Yeah, you're paying attention. I just wanted to check if you're still paying attention. Okay, you want some blue? You will get some blue. This is super easy. This is super easy. Look at that. Decrement pop. Remove X counter. And we just add our stuff here, where is the increment color in mem. So we will do like that. Push. You want blue? You will get blue. X 0 1 0 0 0 0. Push. Add. Oh no, we can just load and then do the second operand. Add and then push. Then to RGB in blah. That's it. That should add your blue. Still recording. Okay. Here we go. Okay, now we should have some blue. Oh no. Uh-oh. Broken. What did I do? What did I do? Oh. Is there some console output? Add. Okay. Push 4. Jump not 0. Push 4. Load. Push. Add. There is a store missing. Store, yeah, you're right. That's what was missing. Ha! So beautiful. We have some extras white spaces here. That's a copy protection. You can see the copyright infringement if your white spaces are missing or they changed or whatever. Too many white spaces here. Yeah, store was missing. You're right. Okay, Yeah, here you go. It's a little bit. Yes. Now we should maybe add 16 to have like RGB more. I don't know. Let's change. That works. That works. Okay. We don't increment anymore. We take that and increment RGB color store here. We add and then we just add 16. Here we go. And store it. Easy as that. Run. Nah, we need here, we need that. Yeah, this is it. Green is pulsing and red and blue is combined. And we can do it even faster. Should we run it faster? Faster, Era? Here we go. Let's 11,000 frames. Oh, sorry. Web save colors. It was too fast. That's cool. Okay, now you write the games. I see you tomorrow. That's cool. That's cool. Oh shit! Yeah, I love it. Epsilon, but this is not really compact. We need a little bit more of stuff there, I guess. But we have a working assembly, IDE. Oh shit. Okay, yeah, I go to sleep. It's amazing. I love it. I will check it in and you can experiment. Add and sub. Here we go. Commit. Yeah. If you doubt me, then I come up with stuff like that, and coding for 30 years. I guess every one of you can do that just because of their experience. We just don't want to. Every one of us can do this because of the experience, but we are bored doing so. In that case, we have a purpose to upload it to this thingy. Okay, we don't have RGB, but yeah. Yeah. It's always a little bit harder to moderate and talk and to listen and code at the same time, especially if it's dreadful debugging. But sometimes it works out, and I'm very happy with the result. I think I will stream tomorrow. I want to really have something working. Beautify this a little bit, add some opcodes, maybe write a snake or something, and try to upload it. This will be hard to complete. Let's see. I need a video on weekend again. Okay. Good night, everyone. Was really cool today. Thank you for the super chats who for the people who super chatted, and for the subs on Twitch and whatever, and donations on PayPal. Yeah, and yeah, enjoy the code. I will drop. Casper's brushing teeth. Yeah. Oh, it takes the most time. Always debugging takes the most time. I guess everyone else is sleeping, or do I raid someone? No. I'm not feeling like doing anything anymore. Just want to sleep. Okay, I will drop the link. Where is it? GitHub. Oh. GitHub. Where's my repo? Where's my Debo repo? IDE. That's so stupid. I called it IDE and it's JavaScript updated 2 minutes ago. Bitluni IDE. Here we go. Here's the link. And I say good night. Bye bye everyone.